Hello everyone, good evening. So today we are trying to solve the questions for the AP Calculus exam. We are looking into the free response questions and we'll be looking them year by year. So past year questions means here we are dealing with the 2024 paper. Now the solutions to these questions are usually quite short. In fact, sometimes the solutions are even shorter than the questions. Okay, please do not be intimidated by the large volumes of texts in the question. Okay, the question is supposed to furnish you with all types of data so that you can make reasonable conclusions from it and arrive at the answer. All right, we will look into the different techniques by which we can solve the problem, and if needed I'll also give you the theoretical backdrop to some of these solutions. Okay, sometimes you might need to know a bit of theory that is probably not relevant to this particular chapter but overall required for mathematics as a whole. All right, okay, so let us delve into the problem. This is the first problem. Now the structure is a bit weird. The table is given first and then the question. Usually the question text appears first and then you have the table, but let us not delve into such details. What we have is time t in minutes and the temperature, which is given as a function of t named as c. All right, so t, the input in minutes, and c of t, the temperature in degrees Celsius. Okay, so the temperature of coffee in a cup at a time t minutes is modeled by the decreasing differentiable function c. So two information is available from this statement. The function is decreasing and the function is differentiable. Okay, now you have to first try to understand what type of function this could be. A decreasing function that will never decrease to be negative, right? Because if you keep a cup of boiling coffee, it might grow cold enough to be at room temperature but will never freeze on its own. Okay, unless you're keeping it inside a refrigerator. All right, which is not the case here because it would have been mentioned otherwise. All right, so basically at time 0 you have boiling hot coffee. Okay, at time 3 the coffee temperature is at 85 degrees Celsius. Probably that would also cause scalding of your tongue if you have drunk it accidentally. At time 7 the temperature is 69 degrees Celsius, and at time 12 the temperature is 55. Still not drinkable, right? You have to keep it for quite a bit more so that it becomes comfortable to taste. Okay, because extremely hot food will first of all scald your tongue, and second of all you will not enjoy the flavor of it. Okay, all right, so coffee stuff aside, let us look into what the function says. The function is decreasing, right? So think of a function that is decreasing but which does not go to negatives. Okay, so it cannot be a linear function, right? It cannot be a minus bx, something like that, where a is a constant, because as time by x I mean t, right? So a minus bt, so depending on the constants, as t gets larger, sometime bt will be larger than a and it will send the function into negatives. That cannot happen. So we have to look into a decay sort of function which will tend to 0 but it will never cross 0 and go back into negative, or it will tend to a particular value, may or may not be 0. Okay, I took 0 as an example of water, but hey, if you are keeping coffee in a normal room that has some ceiling room temperature, then the coffee will after a finite amount of time reach that room temperature and not cool any further, because there are no external forces cooling the coffee. Okay, it will stay the same as the room temperature. For 0 less than t less than 12, the selected values of c dash t are given in the table. Okay, so the values of c dash t are given, and what do we have to do? Okay, these are the values of ct, not c dash t. All right, we have to approximate c dash 5 using the average rate of change of c. Now approximation of a function on a time that is not given in the table. So time is given as 0, 3, 7, 12. So how can we approximate? The best, well, we cannot call it the best, the easiest way to approximate is by joining a line, right? Now we have to first find out the rate of change, right? Approximate c dash 5 using the average rate of change of c over the interval. So what is the average rate of change? It will basically be the slope of the line that joins all of these points, isn't it? So we will take the entire line. It says from 3 to 7, so from 3 to 7 we will take the complete line. Okay, now I hope you remember how we used to calculate the slope of a line segment. It was very easy. The formula was I'll write it down for those of you that do not remember it. But these are general things, you should be able to remember it. So slope of a line joining x1 y1 and x2 y2. This is basically m denoted by the slope is denoted by m, and this is given by y2 minus y1 divided by x2 minus x1. Here the coordinates are in the form of t comma c of t, right? So the approximation would be this would be well, we have to put the sign for approximation. That would be c dash 7, I'm sorry, c7, c at time 7 minus c at time 3 by x2 minus x1, right? So 7 minus 3. Let me know if we have understood this portion. Okay, now I'm quite sure you must have understood this section, because the coordinates given in this question are in the form of t comma ct. How do we know that? We know that from the table, right? From this table we can see that this is x and this is y, the dependent variable and the independent variable. T is the independent variable, ct is the dependent variable, because we can change, or nature changes t, that is independent, right? Nature does not depend on anything. And then c, the function, that depends on the value of t that is inside it, okay, or the input, the parameter. All right, so calculate this from the table, you will get your answer quite easily. Now c dash 5, this will be approximately equal to c7. What is c7? c7 is 69 minus c3, c3 is 85, so divided by 4, which is equal to, now here when we are approximating c dash 5, we will use the approximation sign, okay. Now when we are calculating the actual value, we would be using the equals to sign, because the actual value is not an approximation, the formula is the approximation, okay. So please make sure that you are not using equals to in both places or the approximation sign in both places. You have to know which one is getting approximated and which one is not. So these are technical points, but then again these technical points fetch you marks, okay. If you look at the marking scheme, a lot of points are given. We don't need to go through all of the marking rubrics in detail, but just know that the people that check these questions look into all of these technical details as well. All right, so do not write anything randomly unless you are aware of it. Okay, so this is minus 16 by 4, right? 69 minus 85 is minus 16. Minus 16 by 4 will give you minus 4. Now what are we dividing? We are dividing c7 divided by, we are dividing c of t by t, right? So c of t is represented by the units of degree Celsius and t is represented by minutes. So minus 4 degrees Celsius per minute. It is mentioned in the marking rubrics that the portion of marks allotted for this is not to be allotted if you miss the units. All right, so this is common sense. Basically, anytime you are supposed to get some marks that includes a quantity that has units as an answer, you will not be awarded the full marks if you miss the unit. Okay, so please make sure that you understand the unit and note it down. All right, there is a escape route here. If you do not understand what unit are you supposed to put, just write minus 4 degree Celsius per minute. You don't need to simplify it because sometimes it simplifies. Okay, here you cannot simplify because one is temperature, the other is time. They do not relate. But sometimes in physics you have observed that it boils down to the dimensions. You can have squares of distances by distance, kilometer square by kilometer. So you cannot write that. You just have to write kilometer then in that case. I'm just telling you this because sometimes the units can be cancelled, but in this case they cannot. So leave it as it is. And if it can be cancelled, do cancel it. Otherwise it will still fall in the category of wrong units. All right. So C-5 turns out to be minus 4 degrees Celsius per minute. This is the rate of change. What does minus 4 degrees Celsius per minute rate of change mean? That means it's decreasing. Okay. Which is consistent with the theme of the problem, in so that a hot cup of coffee kept in room temperature would slowly decrease and fix its temperature at equality with the room temperature itself. Alright, so please be aware of it, that the negative sign is quite important. Do not think that negative sign is an error and try to eliminate it. Okay, that is also mentioned in the marking rubrics, that students who change the order to give them a positive answer will face a penalty. Or you could write it as decreasing by 4 degrees Celsius per minute. That is also acceptable. Okay, but you have to convey the sense that you know that this is decreasing. All right, so this is the first part done. I told you, right, show the work that leads to your answer and include units of measure. See, units of measure are included and we showed the work also. So I hope you understood the logic. It's as simple as slope. It's a straight line joining between 3 and 7. We do not have any fancy quadratic approximation or so on, just a straight line. We find c-5 and we get our answer. Alright, so this is done. This can also be explained via the mean value theorems. So for those of you that have gone through that portion, please make sure that you collate those two as well. Alright, I am keeping it simple, I am not explaining that portion. Alright, now the next question. The next section tells you that use a left Riemann sum with 3 subintervals indicated by the data. So what are the 3 subintervals indicated by the data? 0 to 3, 3 to 7 and 7 to 12, right? I'm looking at the table. So 0 to 3, 3 to 7 and 7 to 12. There are 4 points given in the data, so there will be 3 subintervals between them. 0 to 3, 3 to 7, 7 to 12. We have to use the left Riemann sum. So left Riemann sum, I am sure you are aware of the formula. Use the left Riemann sum with 3 subintervals to approximate the value of integration 0 to 12 ct. Interpret the meaning of 1 by 12 0 to 12 ct in the context of the problem. So first we have to calculate the value, then we have to give the interpretation. So this is a very good question because this mixes the concept of mathematics and physics. Maths people usually do the calculations and physics people usually interpret the results. Alright, so we have to do both of them. We have to don the hats of a mathematician as well as a physicist. Let's go. So for the left Riemann sum, we would just be using the calculations of the intervals, right? So 0 to 12 c dashed t, no, just ct, 0 to 12 ct dt. Do not forget to include the dt, okay, because you cannot integrate a function that has no derivatives on it, right? How will you integrate then? A function has to be differentiated first and then integrated first, all right? Or it has to be capable of getting differentiated and then you will integrate it. So do not miss this dt, otherwise it will cause an error. So this will be approximately equal to, you will go interval by interval, right? So 3 minus 0, difference between intervals, into c0. This is why we are using the left Riemann integral, not the right integral. Right Riemann integral would be c3. Okay, so difference between intervals and then either the left endpoint, that is the lower endpoint, or the right endpoint. All right, so here they have asked us for the left endpoint, we will go for the left endpoint. So 3 minus 0 into c0 plus the next point will be, the next point was 7, right? So 7 minus 3 c3, again going for the leftmost point, plus 12 minus 7 into c7. I hope you understand the pattern. We are just going for the left Riemann integrals. Now all that remains is to place the values. Here again equals to sign, because the formula is the approximation, the calculations are exact, okay, because the values are given in the table. Be aware of what you are putting where. So 0, okay, so 3 minus 0, this is 3, c0 is 100, so 3 into 100 plus 7 minus 3 will be 4, c3 is 85 plus 5 into c7 is 69, right? You add up all of these, you will get 985. All right, so the value that we want is 985. Now what did we calculate? We calculated the area under the curve, right? Supposedly the curve. Well, now you can call anything a curve, but a linear curve is basically a straight line. All right, so the first degree polynomial produces a straight line, and second, third, fourth, they produce curves. All of those can be called as curves because it is a sort of a universal set. Okay, all lines can be curves, but some of them of degree 0 will just be straight lines. They will be curves of slope 0. All right, curves of integer slopes or derivatives that are constant. Okay, constant derivatives. I mean constant slopes, not integer slopes. So just ignore the integer slopes part. Alright, 985. Now if I do 1 by 12 0 to 12 ct dt, what does that mean? So there are 12 intervals and I am dividing it by 12. So that means something relating to average is taking place here, right? So this is the average temperature of the coffee over the interval from T0 to T12. Now T0 to T12, from that integration just above it, 0 to 12 ct dt. This means the sum of all the temperatures that the coffee takes between the times of 0 to 12. Okay, now if we divide it by 12, we'll get the average temperature of the coffee. So this just gives us average temperature of coffee from t equal to 0 to t equal to 12, not seconds, this is in minutes, right? So at any point of time, the average temperature will be given by 1 by 12, 0 to 12 ct dt. Okay, you can put the value of t, put the function, integrate and get your desired result. Right? So this is the physical interpretation, because as we know, average is equal to sum of the quantities divided by count of the quantities. Count of the quantities is 12, sum of the quantities is integration 0 to 12 ct dt, which we approximated it by the Riemann sum. So you can calculate 985 by 12 and get the value if it was wanted. Here they have not asked you the value of the average, so we don't need to calculate it. Okay, now next portion, see, there are 4 subparts. Let us go into the next subpart. So part C asks us, for 12 to 20, the rate of change of temperature of the coffee is modeled by C dash T equal to, okay, so as I was talking about the type of equation, that type of function that you were supposed to be using, I told you that we cannot use a linear function because that would mean it would go into negative. The radioactive decay function is a very appropriate function to use. I call it radioactive decay because that is what you have seen this in first, right? Radioactive decay or population decay, because population can at most decay to 0. You cannot have negative population, right? You can have infinite population while growing, but while declining you cannot have negative population. All right, so same logic, the growth equation or the decay equation, the growth equation is the one in which the exponential part has a positive coefficient, the decay equation has a negative coefficient in the power of the exponential function. So we are given a decay equation and we are supposed to calculate the rate of change of temperature of a coffee, find the temperature of the coffee at time t equals to 20. Fine. So C dash T is given as minus 24.55 e to the power 0.01 t. Okay, divided by t. Okay, this is positive. This is given as the decay function. All right, now the decay function will just give you the amount of decay that happens after the table ends. Okay, the table ends at t equal to 12, right? So when the table ends at t equal to 12, you have to figure out what the decay after 12 to 20 is supposed to be. You can subtract that from the end value at 12 and get your answer. Okay, so this function does not have an initial condition. Okay, it's not something minus this. So that means you will not only have to calculate the decay but also subtract it from the last known value of C12. Okay, because this is range from t belong, this is from 12 comma 20, right? So your temperature at 20, C20, this would turn out to be C12 plus this integration, right? 12 to 20 C dash T dt. I hope I could explain you the logic for this, because the negative sign is already there, right? You might be asking, sir, why plus? You know that it is going to decay. I know that it's going to decay because the function is given in a way that decay is explained, because it's given in negative. So if we have to subtract something, we can either subtract a positive number or add a negative number. Here we are doing the latter. Okay, we are adding a negative number. So C12 plus 12 to 20 C dash t dt. We can integrate it. I hope you know the integrations here. Integration is not that difficult, right? You just have to go e to the power t by t. You do that integration and you will get the value. C12 is given. Okay, so this will approximately be, the value of C12 is given to be 55, I think, right? Yes, 55. Sorry, 55. And if you calculate this value, you are allowed a calculator, right? A graphing calculator. It was given in the question paper. So a graphing calculator will of course contain the normal integration functions as well. So input the function, use numerical methods of integration, and you can do it quite easily. Okay, otherwise you can use integration by parts and solve the theoretical, the improper integral, and then put the limits for the proper integral, right? So the numerical value of this portion will be up to 3 decimal places. This will be 14.670, 14.671. okay, we approximated it up to 3 decimal places. So this is at degree Celsius, right? This is approximated, and this will be equal to 40.33 degree Celsius. Okay, we approximated this again. We had 3 places of decimal here. We approximate this again to 2 places of decimal, and this is the temperature that we have obtained at C when time is 20. All right. So the temperature of coffee at time t equal to 20 is 40.33 degrees Celsius. Okay, we obtained this because we knew how much decay would occur, and we know from which point the decay is starting. The decay is starting from C12. Okay, this makes complete sense. We will go for the last subpart. The last subpart says, for the model defined in part C, it can be shown that C double dash t. Okay, so they have calculated the second derivative. They have already done it for us, so no headache here. So C double dash t is given to be 24.0.24. okay, that is because the coefficient of e to the power 0.01 t gets divided, right? So 0.2455 e to the power 0.01 t into 100 minus t divided by t square. Okay, here again you can either apply the chain rule or go for the division rule of derivatives, right? D derivative of u by v equal to v square, and then you have u v dashed minus v dashed u, right? You can either go for this or you can go for the chain rule, like u into 1 by v. All right, same thing. So anyway, this is given to us. Now they have asked you to determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. Okay, so 2 things. First of all, the physical meaning of derivatives. Derivatives give you the rate of change, right? Now we are asked to calculate whether the change is occurring in a decreasing or an increasing way. So we are asked to calculate the rate of change itself. Okay, so rate of change means derivative, and rate of change means derivative again. So rate of change will be derivative of derivative, which is the second derivative. This is given. We just have to check if this is positive or negative. So what are the values given? The values given are t belongs to 12, 20. End points are excluded, I think. Yeah, end points are excluded. Now, if plugging in 12 or 20 provides a positive answer, then our rate of change is increasing. If they give us a negative answer, then the rate of change is decreasing. All right. So as you can see, 0.2455 is positive. The exponential function will always be positive. 100 minus t. 100 minus t is positive for t 12, 20 and everything between it. 100 minus t will only be negative if t is beyond 100, right? And t square is always positive. So C dash t is clearly positive. I missed the L. Clearly positive for t belongs to 12, 20. This implies the temperature of coffee changes at an increasing rate. Many of you that consume hot drinks regularly would have observed this. You get a warm cup of drink, you try to take a sip, it's way too hot, you put it down, you talk with people, you have some other snacks. When you come back to it, it's lukewarm. You spend the same amount of time, come back, and it will become colder, right? Because as the temperature starts decreasing, it decreases in an increasing rate. All right, so this is quite unique to the law of cooling. So this is technically taught in first years of graduate courses under the topic Newton's laws of cooling, okay, or you will find it in easier calculus textbooks on radioactive decay, etc. So applications of the radioactive decay formula. Temperature of coffee changes at an increasing rate. This means the change of the temperature, whether it's increasing or decreasing, here it's decreasing, the rate of decrease increases. That means the lower the temperature, the faster it will be cooling. Okay, so this is why that happens. So you have a hot coffee on your table, you spend, let's say, 5 minutes, you come back to it, it will be less hot. Okay, now you spend 5 more minutes, come back to it, the temperature that reduced in the first 5 minutes will be lower than the temperature that gets reduced in the last 5 minutes. Okay, so it will cool faster. All right, so this is why it happens. All right, so you got a physical explanation for a phenomena which could be observed in daily life but has applications of mathematics to it. So when people ask, hey, this calculus, when will you ever apply it, we just only studied it in school, that is not true. Okay, we only say that because we do not think hard enough to find out where the applications of these things might be, or we may not even be told, because sometimes you just need to know the formula to pass the exam. Okay, it happens quite a lot here in India. But I hope that the people that are taking the exam takes this seriously, because you can see the calculations are not too difficult. Okay, the easiest part is the calculations, because you are allowed a graphing calculator that should have all of these capabilities, all the numerical capabilities to solve this type of problems. You just have to understand what the various variables, the various equations, the differentiation, the integration, what do they represent. Okay, what is the physical meaning of it. If you can make the sense geometrically or analytically of these problems, you should not have much difficulty in passing these exams. Okay, also make sure that the technicalities are correct. I'm sure your teachers will be helping you with this, but if you need any more help with these type of exams or these type of problems, do not hesitate to contact this number. You can find it just below my face. Okay, it's just below my camera panel. Now you are also welcome to comment your questions and queries on the comment section of this video, but if you do not feel comfortable doing that, please drop a WhatsApp message to this number. Our team will get back to you. All right, anyway, I'll get back to you with the second question in the next video. Until that, take care, and please make sure that you are looking into the concepts much more carefully rather than just rote learning the formula and trying to applying the sums. Okay, bye, I'll see you in the next one. Take care.